Math 3, Unit 9, Section 6. Solving logarithmic equations using the laws of logs. So, you'll remember our laws at the top. We are going to condense each side of our expression as much as we can until we get one logarithm on each side. And that logarithm should match so that we can set things equal to each other and ignore the logs all completely at the end. So we're just going to start solving. Remember, your laws are listed at the top if you need them. So this first one, keeping in mind we want to condense each side so that I just have one log of the same base on each side and an answer. So log base 6 of something and log base 6 of something. So you'll notice that this 2 is not part of the log base 6 of something. This 2 must be moved back. So anything that's multiplied out to the front means it can be written as an exponent. So the left-hand side we're going to keep exactly the same, and all we're going to do on the right-hand side is move the 2 to the exponent place. So this is 3 squared. Okay, once you get log base 6 of something equals log base 6 of something, those somethings are equal. Okay, see how this is both log base 6 on each side? That means x over 7 equals 3 squared. What's 3 squared? 9. So how do we solve for x? Multiply by 7 on each side. X equals 9 times 7, which is 63. All right, another one. We got a couple more things to condense this time, so we're just going to keep adding more on so there's more to condense each time. Let's start always with those exponents. Anything multiplied out to the front becomes an exponent. Now, we didn't do anything to log 4. Log of 4. Okay. Now, addition changes to multiplication and subtraction changes to division. So I have subtraction, I'm going to change it to division. I'm also going to look at this 2 to the 6th power. 2 to the 6th power is 2 times 2 times 2 times 2 times 2 times 2, which is 64. So I'm going to rewrite that as well. So the left-hand side stays exactly the same. There's no other logs to condense it with. So I just keep it like that as one log all by itself on the left. Let's get one log all by itself on the right. Subtraction changes to division. So this 2 to the 6th needs to be divided by 4. So it'd be 64 divided by 4. Or 2 to the 6th over 4. I just changed the 2 to the 6th to a 64. All right. So we get log of x squared equals log of 64 divided by 4, which is 16. Now, log 1 on each side with the same exact base. What base is this? If it's not listed, it's a 10. So the same base, which means x squared equals 16. What does x equal? 4. Now remember, we don't want a negative number where the x is, so I can't do a negative 4. Otherwise I would do plus or minus 4, but I know I can't have a negative number where x is. All right. Subtraction changes to division. So we're going to divide what's in parentheses. If you have one log on each side, then we set our answers equal to each other. So 3x plus 5 over 7x plus 2 equals 2. We want to get rid of that denominator, so I'm going to multiply by 7x plus 2 on each side. Which means, ooh, it simplifies there. Don't get rid of that 3x. 3x plus 5. I don't need parentheses. 3x plus 5 equals 2 times 7x plus 2, which is 14x. 2 times 7x is 14x. 2 times 2 is 4. And then you're going to solve this. So (3x plus 5 equals 14x plus 4). You're going to subtract the 3 and subtract the 4 to the other side. 14x minus 3 is 11x. 5 minus 4 is 1. So then we're going to divide by 11. So that we get x equals 1/11. Probably should have wrote that up here so that I don't go into this question down here too much. All right, next one. Log base 11 of something equals log base 11 of something. Set the somethings equal. 2 to the 3x equals 32. When you have something in exponential form like that, you can find out the exponent if you know two bases that are equal to each other. So if I rewrite 32 as 2 to the 5th, because 2 to the 5th equals 32, then I can set my exponents equal to each other. So if 3x equals 5, then x equals 5/3. How do I get 5/3? You just divide each side by 3. All right, next one. I have two different logs, not different. I have two logs with the same base, different answers, on the left-hand side. One on the right-hand side. That means the right-hand side one stays there. It's fine right now. But I want to condense these into one log, base 8. Addition means you multiply x times x minus 6. Remember, that right-hand side is going to stay the same because it's already condensed as one log. Now, log base 8 of something equals log base 8 of something. This means x times x minus 6 equals 7. X times x minus 6, x times x is x squared, x times negative 6 is negative 6x. That's going to be equal to 7. Trinomial if it's equal to 0, right? Or if you can solve a trinomial if it's equal to 0. All right, so 7 minus 7 is 0. How did I know it was going to be a trinomial? I have a squared term, an x to the first, and a constant. They just have to be all on the same side if we're going to solve for x. So now it's a trinomial, which means I can do one of two things. Well, several things, but mostly we either factor or use quadratic formula. If we can factor it, we're going to factor it. So let's do guess and check here. X times x is x squared. What multiplies to give you negative 7 and adds to give you negative 6? All right, let's check this. X times x is x squared. X times negative 7 is negative 7x plus 1x. Negative 7x plus 1x is negative 6. And 1 times negative 7 is negative 7. All right. When you have two things multiplied together to give you 0, what do you do to solve for each of those? Set them equal to 0. X minus 1 equals 0. And x minus 7 equals 0. So x can be 1. Oh, sorry, x plus 1, which means x could be negative 1. Or x could be 7. Can you have a negative number written in there for x? No. So our only answer is x equals 7. All right, moving to the right. We want all as one log on the left-hand side, so this subtraction means we're going to change to division. Log base 2 of 5x minus 4 divided by x equals log base 2 of 3. We didn't need to condense anything on this side. It was already one log. Once you have one log on each side, like that's the goal until you have one on each side and they match. Log base 2 and log base 2, that means these answers are equal to each other. Okay, how do we solve? Let's multiply this x to the other side so we don't have any more denominators. 5x minus 4 equals 3x. We're going to subtract 5x to get all of our x's together. We get negative 4 equals negative 2x. Divide by that negative 2. Negative 2 divided by negative 2 is 1, so that reduces. Negative 4 divided by negative 2 is positive 2. All right, next page. All right, so we have more logarithms. We're still going to condense them, but we're going to run into an issue where we won't have one log on each side. So when we have one log on each side, we set those answers equal to each other. That's why I was circling those. We set those equal to each other. That won't happen over here because we don't have any logs on the right-hand side. So instead, we'll change to exponential form. But all the other steps are the same. So let's go ahead and condense. Log base 4. Subtraction means to divide. 28 divided by x. The right-hand side stays the same. Now at this point, if there was a log base 4 on both sides, we would set our two answers equal to each other, but there's not. So that log function is not taking place on both sides, which means you change to exponential form. 4 to the second power is 28 over x. That's why I always call this the answer, because it's the answer to the exponential form. All right, so that's going to give me 16 equals 28 over x. You can multiply the x to the other side, which gives you 16x equals 28. And then you can divide by 16, which means x equals 28 over 16, which does reduce to 7 over 4. Okay, moving to the right. Condense the left-hand side first. We need only one log right here. So, addition means you change to multiplication. X times 4 is 4x. When you have one log on one side, none on the other, change to exponential form. But you have to know your base here. If it's not written, it's a 10. 10 to the third power equals 4x. 1,000 equals 4x. 10 times 10 times 10 is 1,000. So we're going to divide by 4. 10,000 divided by 4 gives you 250. All right, Moving to the right. We have nothing to condense. This is as condensed as it gets. So we change to exponential form. But you have to remember, ln is base e. So this is e to the -2 equals x. So your answer here for x is already isolated. So let's just change it so that we have no negative exponents, because that's normally how we want to write it. So -2 means 1 over e squared. All right. Next one. Condense as much as you can. So log base 3. Addition means multiply. So you're doing 3 times x minus 5. You can do x minus 5 times 3. We always usually put our constant out in front so we can distribute it through. Okay. When you have 1 log left, you can change to exponential form. So 3 to the 4th power equals 3 times x minus 5. 3 to the 4th, 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. 81 equals 3x minus 15. How did I get 3x minus 15? Distributed. 3 times x, 3 times -5. Add 15 to each side. (96) equals 3x. Divide by 3. 9 divided by 3 is 3. 6 divided by 3 is 2. X equals 32. Next one. Condense to 1 logarithm. Oh, hold up. There is, almost too far. There is a 3 out in front. It hasn't been a while since we moved an exponent to the correct place. So this would be ln 2 to the 3rd plus ln x equals 5. Now we can condense our addition to multiplication. All right, 2 to the 3rd is 8, so this is going to be 8 times x. Now we can change to exponential form because I have 1 logarithm left. It is the natural logarithm, so my base is e. That means e to the 5th equals 8x. Solve for x, and you need to divide by 8. So x equals e to the 5th over 8. Last page. Solve for x. On problems involving pi or e, leave answers in terms of pi or e. Do not approximate, meaning don't plug it into your calculator and find a decimal value. No reason for that. We're just going to leave it as an expression. All right. Moving the exponent first. Log base pi of 5 squared plus log base pi of x equals 3. All right, the addition tells us to change to multiplication in order to condense to 1 log of base pi. 5 squared is 25, so when we multiply these together, we get 25x. 25 times x. Addition changes to multiplication. We still have to solve for x. So we have to, when we have 1 log, we need to write it in exponential form. Your base is pi, raised to your exponent is 3, equals 25x. Uh-oh, where's my 5? Solve for x by dividing by 25 on each side. X equals pi to the 3rd over 25. Don't approximate. Don't plug it into your calculator. All right. Next one. I don't have any numbers out in front to change to an exponent. So, I mean, this is technically a -1 out in front. If I change that to an exponent, it moves it to the denominator. Oh wait, but subtraction means to divide anyway, so that's already going to get moved to the denominator. That's why math works, right? So subtraction changes to division. 3x divided by x minus 2. All right, here we go. Once you have one log total, change to exponential form. 7 to the 0 power equals 3x over x minus 2. 7 to the 0 power is 1. I don't know why I changed colors yet. Multiply x minus 2 to the other side. One times x minus 2 is x minus 2. I don't need the parentheses anymore. I don't know. If all we have is x minus 2 left, there's no other operations. So, we're going to subtract x. Negative 2 equals 2x. Divide by 2. X equals negative 1. Let's look up here. Can x equal a negative number? Negative 1 times 3 will give you negative 3. We cannot have a negative there. So, we have no other answers. What's our answer? No solution. All right, you're working on Unit 9, Worksheet 6.